Finite automata. Finite automata is nothing but a abstract model of computer which consisting of input file, output file and also control unit. So control unit takes the input and processes the input and as well as it going to be producing the output. Finite automata can be represented by using the mathematical notation, that is nothing but a 5 tuple notation. That 5 tuples are Q, sigma, delta, Q naught, F. Q is nothing but a set of states and sigma is nothing but a set of input symbols and delta is a transition function, we can say. It takes one state to another, it gives one state to another state for given input. For example, transition function of Q naught on A, it may which produces one state to another state for a given input. By taking the input symbol on the state, it generates any state. And Q naught is the initial state, F is the final state. Like this, transition function, it gives one state to another state for a given input. So this is nothing but a finite automata. This finite automata can be represented, finite automata classified into two types: deterministic finite automata, non-deterministic finite automata, or you can say it as a NFA also. What is deterministic finite automata and how to design a DFA, we will see now. So definition of deterministic finite automata and how to design a DFA, we will see now. What is a DFA? Deterministic. What is the meaning of deterministic means? Deterministic means with one state it cannot go to more, with one input symbol it cannot go to more than one state. That is the meaning of deterministic. Deterministic means with one input symbol, with one input symbol it cannot go to more than one state. That is the meaning of deterministic. It cannot go to more than one state. That is the meaning of deterministic. What does it mean? Means, for example, if you are having the Q naught state with one input symbol, which is nothing but I am considering A as the input symbol. So on input symbol A, it is going to the Q1 state. Let's consider. And again with the same input symbol, it cannot go to more than one state. This is not possible in a DFA. With the same input symbols, it cannot go to more than one state. Here Q naught on A, it is going to the Q1. Again Q naught on A, it is going to the Q naught. So this is not possible in a DFA. That is the meaning of deterministic. With one input symbol, it cannot go to more than one state. This you need to remember in your designing of a DFA. So now we will see how can we represent a DFA. DFA can be represented by using the mathematical notation, same again 5 tuple notation. That tuple are Q, sigma, delta, Q naught, F. So here Q is nothing but a set of states. So here to design a finite automata, we will be having some number of states. All that states will be represented by using the Q. Sigma is nothing but a set of input symbols. So on the states, we need to produce an input that will be represented by using the sigma. Delta is a transition function. This is only takes one state to maybe another state or the same state by taking the input. This is the main important concept, transition function. Q naught is the initial state. Why we need to use the initial state means the machine always should start from the initial state. To represent the starting of the input symbol, you need to mention the Q naught. F represents the final state, which means that the processing is over by reaching that state. So here DFA is nothing but a deterministic finite automata. You need to write what is the meaning of deterministic. Next you need to mention DFA mathematical notation. Now we will see one example.